All right, so now that we got the connection status component up and running, what we can do next is start working on this main button logic. However, before we just jump right into that, I want to kind of take a step back and do a little recap of exactly how this app is going to work. So whenever we hit that go button, what's going to happen is my device is going to send a message through the core server to the receiving device. And then once this receiving device receives this, all it's going to do is it's going to send back a message back through the server to my device. And we'll say that this first request, we're going to call it the ping request. And then this response, we'll call it the pong. So a ping pong message, pretty simple architecture. But before digging into the code, let's go ahead and take a look at the structure for exactly how these blocks are going to be formatted. So these blocks, or in other words, chunks of data that are going to be sent between devices, they always need to have a unique ID. And for this, you can just have any valid UUID. And the reason that we need this is just to ensure that this core server, it isn't processing the same exact blocks again and again and again. It also allows for you to specify an amount. We're not going to need this in this tutorial. This is just so if you ever want to transfer some messaging credits from one device to another, then you can do it right there. Again, like I said, this is just going to be 0 for this tutorial. The recipient and the sender, this is pretty simple. It's the account number of the receiving device and the one who sent this block. And this transaction fee, this we have set up on the core to be 1 by default. And the reason that we have this is kind of for security purposes. If anyone ever steals my device, it effectively throttles the amount of traffic or messages they can send back and forth. So the core server, like I said, just requires 1 messaging credit to send a message to another device on the network. Now this payload we'll dig into in just a second, but lastly, the signature field is just for the digital signing process to ensure that the sender is indeed the one who is sending this message. So now on to the payload. So if we take a look at the source code for the server, we can see that the payload is a JSON field. So you can include as this payload any valid JSON. However, for TNBOS, just to keep things standardized, we always shape the payload in this format. We have a PID, which stands for process ID, and what this effectively translates to is the ID of the application that is sending or receiving this data. In that way, let me pop this open again. Whenever we have blocks coming into TNBOS, TNBOS is going to know which app to route those blocks to depending on this process ID. So again, for us, it's just going to be a speed test, but for chat, it's chat, so on and so forth. Basically saying which app is this data for. Now, aside from that, we have this FN in params value because essentially, whenever we are sending data to another device, in a lot of ways, it works similar to a RPC or a remote procedure call or remote function call, where we are essentially calling a function on another device. So the two functions that we're going to be writing are a ping function and then a pong function. And for both of those functions, the params are going to be the same. And that is just going to be the run ID. And the reason for that is whenever I send out this request and that device sends something back, I know which run it's referring to. So now let me go ahead and open my IDE and start writing some of the TypeScript definitions for, I'll start with these functions. So in types, I'm going to create a new TypeScript file and I'll say FNS. I don't like using the word function anywhere because it's a reserved keyword. So that's why I decided to use FN rather than function in a lot of these places. So export enum and I'll say speed test FN. And like I said, we're going to have two functions, a ping and a pong. And pong. And for each of these functions, we'll write a separate interface. And for this, I'll say the ping params, whenever we call this function. This is just going to take in a run ID. And this is going to be a string value. And then I'll do the same exact thing for the pong function. So whenever you use the pong function, also pass in params of the run ID. Now we can probably combine these into one interface, but I like to be super explicit whenever I'm writing the params for each function. And on that note, what we can do now is just go ahead and import everything. So this is under functions, just import all of that. All right. Now from here, what I like to do is create utility functions for generating these payloads. And you'll see why in just a second. So under speed test, I'm gonna create a new directory called payloads. And for the naming convention is just the function name followed by payload. So first we'll do the ping. And all right, so for the ping payload, again, it needs three things: process ID, function name, and params. So let me go ahead, and since our process ID is just the app ID, and that is stored in this app registration, I'm going to import the speed test registration. So import speed test registration from apps speed test registration. And then after this, let me go ahead and import some of these types. So all right, so we are going to need this speed test function and these ping params. And no, the only other thing that I need is a little helper interface that I wrote from system types, and that is app payload right there. I'll show you what this is. So all this is saying is that for this interface, it requires a function, which is a string, params, which can be anything, and process ID, which is a string, basically ensuring that we follow this format right here, which is just the TNBOS standard. All right, now this function, say ping payload, it's equal to a function, and this function is going to return that app payload. And the only thing that we're going to be passing in here are params matching the ping params. In other words, in this case, just a run ID. Now, the reason that we're only going to pass this in is because whenever we return this payload, the function name is always going to be equal to speedtestfunction.ping, and the params, those are just going to be set to whatever params that we passed in. And for the process ID, it is speedtest registration, the app ID right there. All right, and this can be our default export. All right, so there we go. This is looking good for our ping payload function. And now let me go ahead and pretty much write the exact same thing for the Pong payload, and we'll just copy this. Replace ping with Pong. And then for uppercase ping, replace it with uppercase Pong. Now, last but not least, just like kind of our standard convention, going to create an index file and export both of these into here. And that way, whenever we use these in our components, then our imports are just a little bit cleaner. So we want to import first ping payload. Then the same thing for Pong payload. Pong, 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 pong. Pong, 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 pong. Ping and Pong. All right, beautiful. Now, just like we wrote those helper functions to generate these payloads, what I also want to do is write helper functions to generate these blocks. And that's just going to make it a lot more clean whenever we work with this in our components. So let me close all this, make a new directory called blocks. And we're going to have two blocks, which is the ping block and the Pong block. So start with the ping block. And import everything I need to. And this is just going to have one function, and I'll say ping block. Comes ping block in. That'll be the default export. All right. So this ping block function, we'll pass in an object, and let me type out the interface right now. So the interface, I'll just say ping block, just to make sure that we pass in all the correct params. So whenever we generate a ping block, or in other words, send a ping block to another device, we need to give it 3 pieces of information. The first one is the network ID. Which network are you going to be sending this over? The other one is the recipient, which is just the account number of the receiving device. And lastly, we need to pass in the params. And these, for this, are just the ping params. So now we can say, actually, let me do this. So ping block and just the structure right here. So network ID, params, and recipients. And actually, since this function right here, it's not only going to generate the ping block, but actually send it over the network. What we can do is make this an async function, because we're going to be awaiting a nested call in here. Now, before we even start writing the block structure, what I want to do is say const. I want to get a property from the system called self, and this refers to basically the self account. In other words, my account on this device. And the reason that I want this is because whenever we generate that block, we need to sign it with our signing key. So that signing key is stored in this self property right here. So we're going to be using that in just a sec. But for now, what I want to do is define, where are you at? Right here. So we're going to start defining this block structure. And what we're going to do is we're going to define all of these properties aside from signature, because signature is going to be generated in a different kind of way. So let me just do that right now. So data, this is going to be equal to an unsigned block. In other words, a block with all these fields excluding the signature. So the first thing that we need to do is specify an amount, and this is just always going to be 0. And then for the ID, remember I said that we need a unique UUID, and instead of writing our own function for that, there is this function right here from the crypto library, random UUID, going to give you a new one each time. Now for the payload, for this, we are going to take that function that we just created, ping payload helper function, and remember this is just going to accept the ping params, and those are these params right here. Now after this, we just need to specify the recipient, which is the receiving account number. The sender, that is on self.account number, basically my own account number. And for the transaction fee, we just created a constant for this core transaction fee, since it's always just 1. So let me clean this up, and all right. So once we have our unsigned block, what we need to do is add the signature to it. And we created a helper function for this as well, which is block sign data. And what do you want to sign? Well, this data right here, this unsigned block. And as the second param, what we need to do is pass in the signing key that we want to sign it with, and that's just self signing key. So again, this self is an object that consists of my account number and the related signing key. So there you go. So the only other thing that we have to do now that we have that block signed, is just send it over the network. So to do this, I'm actually going to return a function called create block. And you can see that it takes a block and the network ID, basically saying what network do you want to send it over. So the block is of course just block, and the network ID is equal to the network ID that we pass in. And just to look at this real quick, again, all this does is it takes a block, which we pass it in, and it sends it over this network. That's it. So now that we have that taken care of for the ping block, I'm going to go ahead and copy this. And pretty much just need to do find and replace to say pong. So replace ping with pong, uppercase, and then ping with pong, just like that. And there you go. So now that we have our 2 block generator helper functions, As always, just go ahead and make an index file. Import ping block. Import ping block on pong block. And export these bad boys, ping and pong block. All right, so now that we got all our helper functions written, we can finally hop back into main button and start hooking everything up. All right, so let me import everything I'm gonna need. And all right. So again, what is gonna happen whenever we click this go button is it's gonna send a block to this account on this network. And that is our active account number and active network that we're gonna need to pluck off. So const active account number, and this is equal to that slice of get active account number. And same thing for the active network ID. So get active network ID. And then aside from this, we're also going to be dispatching that run to our Redux store. So for this, we need to use dispatch, and this is equal to use dispatch. And the type of this is just our app dispatch. And the other thing that we're going to need is that use is connected hook. Use is connected. And remember, we use this for our connection status right here. But the reason that we're going to use it in this main button is because if we're not connected, then we want to just make sure that this button is disabled. So on that note, what we can probably write now is that on click handler. So what happens whenever you click the button? I'll say handle click. And since this is going to be sending a block, we'll make it an async function. And all right, so first of all, I want to say that if you are not connected, then we can just go ahead and return. And then what I would actually want to do after this is this. I want to go ahead and generate a run ID. And run ID, this is just going to be equal to crypto.random UUID. And now that we have that, right after, what I want to do is I want to generate this run and dispatch it to our Redux store. So I'm going to dispatch a new run, and for that I'll say set run. Now the shape of a run, let me just go ahead and see what we need to create a run. Actually, you can probably just do this. Copy all these params and just replace them. So the network ID is going to be equal to our active network ID. And this is probably going to give an issue because this active network ID right here, it can be a string or null. However, we are going to say that we definitely have it because if we're not connected, in other words, if we don't have a network ID, then we're not going to be connected. So this logic is never going to run. So at this point, we can guarantee that we have it. Now for the recipient, this is going to be the active account number. Now for the request date, we can use this utility function right here, current system date. And I'll show you what this is gonna return. Basically just a date formatted in this standardized format. Now for our response date, this is going to be null because remember, whenever we first generate this run, we're gonna send it off to the other device, but we're not gonna, of course, have a response at that time because we don't even know if they're gonna respond. So set that equal to null. This is gonna be set whenever we get a response, of course. Now for the run ID, it's just the same as this run ID right here. And for the status, this is going to be equal to run status pending. So pending by default, and then depending what response we get back, it's either a success or timeout. So this, there we go. Some cleanup. All right, so whenever we click this button, what we'll do is we'll say on click, handle click. So you click the button, what happens? It generates this run, stores it in our Redux store. Now, right after that, we'll go ahead and send out that request. And remember, that function was called ping block. And if we take a look at this interface, we'll see that it requires a network ID. And this is just going to be equal to the active network ID, the recipient active account number. And for those params are just the run ID. So now let me just go ahead and pretty this up. Remove this. And all right. Now to test this out, I do need a connection. So I'm gonna go ahead and open my MacBook right now, and I'm booting up TMBOS. And sweet, now that we are connected, let me go ahead and hop in my network tab. That looks good. Clear this out, and hopefully when I hit go, sweet. All right. And you saw that invalid block receive error message. And that's because we didn't write the logic for my MacBook to actually understand what the heck that block was. So it's probably sending back an error message right now. But before we even fix that, what I want to do is fix this little situation right here. Because the logic that we want is if you are not connected, then I want to just make sure that this button is disabled, since you shouldn't be even allowed to click this, or it shouldn't even look clickable if you don't have a connection. So to that, back in my component is in the styles file, I'll go ahead and add in this disabled mixin. And all right, import CSS. And what this is going to do is just add some disabled styling to the button. And to actually accept these, I need to pass in some props to this container. And I'll just say I'll have an enabled prop, and right now we're probably gonna need to make some adjustments to this, but we'll just say it's enabled. In other words, this button is enabled if you are connected. And now what we can do is say for this Boolean, and I forgot my curly brackets. All right, so this is gonna accept an enabled prop, and with this, what we wanna do is just say, with this enabled prop, we will say that if you are not enabled, then go ahead and render this disabled mixin. Clean this up. And all right, everything looks good. So check it out. All right, so this is pretty cool. So I am not, I'll show you what's going on right here. So right now I am connected to my iMac, but I'm not connected to my Linux desktop. So you can see I have Linux desktop I'm trying to connect to right now. It's good. This go button is disabled. However, whenever I choose my iMac, everything is connected, and then I can then send the request. Of course, my iMac still doesn't understand what the heck data it's receiving, so it's sending back an error. But yeah, there you go. The basic block structure is working. And also, this is the very first time where we are now sending data to another device, and it is sending data back. Even though it doesn't understand what that data is, at least we have something up and running, communicating. Pretty cool checkpoint. So in the next video, what we'll do is we'll start working on this timer right here, get this up and running, and then the history table from there. So yeah, making some sweet progress here. See you next video.